Welcome to our channel. Today we continue the previous topic on HCF concept. In the previous video we discussed about or we started a topic called HCF concept and that we discussed the basic definition regarding HCF concept. So how to find the factors of a given number and how to find the HCF of a given number, and we discussed about method 1 and method 2 in the previous video. And now in this video we'll continue from method 3 here. So what method 3 is actually say. So in order to understand clearly, first we'll discuss about or first we compare that one with LCM concept. If we compare it with LCM concept, then it is easy for us to understand the HCF concept here. As you know that HCF means highest common factor. Sometimes it is also known as the greatest common divisor. So both are same here. So in the model 3 or method 3, what we discussed means LCM of co-prime numbers will always be equals to the product of co-prime numbers. This point we discussed regarding for LCM concepts. So let us consider one example here. LCM of 3 comma 5. So if you observe here 3 and 5 are both co-prime. Co-prime means the there is only one factor present in between those numbers. There is only one factor present for those given numbers here. So here, so the factors of 3 are only 1 comma 3 and the factors of 5 are 1 comma 5. So we can say that the LCM will be simply the product. So simply 3 into 5 will be equals to 15. This point we discussed under LCM concept. So the same point we applied for HCF concept here. So here HCF of co-prime numbers will always be equals to 1 irrespective of any of the numbers. Suppose let us consider one example HCF of 3 comma 5. So here the factors of 3 are 1 comma 3 and the factors of 5 are 1 comma 5. So what is the common factor, and that will be the highest factor. So the common factor present in both the things will be 1 and that will be the highest. So the HCF of 3 comma 5 will be 1 here. Let us consider one more example here is HCF of 6 comma 7. So we observe here co-prime numbers, but here 6 is not a co-prime number here. But we observe here the main idea behind here. So the common factor will always has to be one present in between the two numbers. Suppose the factors of 6 are 1, 2, and 3, and the factors of 7 are 1 and 7. If you observe here, what will be the common factor present in both the numbers? So the common factor present in both the numbers will be here only 1. So the highest common factor will be 1 here. So HCF, let us consider one more example. HCF of 9 comma 13. For this also the highest common factor is 1 here. So from this we can note one point here is HCF of two consecutive natural numbers. Consecutive natural numbers will always be equals to 1 here. HCF of two consecutive natural numbers will always be equals to 1. Let us consider one example here is, suppose in order to find HCF of p comma p plus 10 comma p plus 15 comma p plus 25 comma p plus 26, I need to find the HCF for this one. So here p may be any natural number. P may be any natural number. So natural numbers means so numbers lying from 1 to infinity. So suppose if I take p as 1 here, it will be like 1 comma 11 comma 16 comma 26 comma 27. So here the common factor present in between the highest common factor present here is only 1 here. So remember that HCF of any two consecutive natural numbers, and HCF of any two consecutive natural numbers will always be equals to 1. Suppose if p I will take it as an odd number or natural number, but it is an odd number. If I take p as a natural number, but it as an odd number, suppose let us consider one example here is HCF of p comma p plus 1 comma p plus 3 comma p plus 5 comma p plus 7. So for these numbers also the HCF will always be equals to 1. So remember one point here is HCF of a comma b comma c. HCF of a comma b comma c will always be equals to 1. will always be equals to 1. Suppose here a comma b comma may be any natural numbers or some natural numbers along with odd numbers. So it follows a property of Pythagorean triplet. It follows a property of Pythagorean triplet here. So the Pythagorean triplet can be written as c square is equals to a square plus b square. But this is not used yet. But for idea case we are saying. So the thing you need to remember is HCF of two co-prime numbers will always be equals to 1. So this is about method 3 here. And let us go for the method 4 here. So what is method 4 here is, so let us compare this one with LCM concept here. So in the LCM concept, we have taken one example here is LCM of 12 comma 15. So in this method, what we do is we take out common factor, we take out a common factor, and after that we are left with only co-prime numbers. After taking out of a common factor, we are left with only co-prime numbers. So suppose I write like this: LCM of this 12 can be written as a 3 fourths is of 12, and this 15 can be written as a 3 fives of 15. And if I take the common factor here present in both the numbers, the common factor is 3. LCM of 4 comma 5. So here 4 comma 5 will be like these are the two co-prime numbers. So it can be written as what, or you can, so L 3 into, so 4 into 5, that can be written as a 20 and 6. So the LCM of these two numbers will be equals to 60. So the similar example consider here is HCF of 12 comma 15 here. HCF of 12 comma 15 here. So this can be written as what? So HCF of 3 into 4 and 3 into 5. And if I take out the common factor outside, 3 into HCF of 4 comma 5. What is the highest common factor present in, suppose for as we told for a co-prime number, so we simply take out the product here. For here also for a two co-prime numbers, so HCF will always be equals to 1. So 3 into, so here the highest common factor present here is only 1, so that is multiplied with 1 here. So the HCF of 12 comma 15 will be 3 here. Let us also consider one more example here is HCF of 15 comma 25 comma 35. 15 comma 25 comma 35. Suppose this can be written as HCF of 3 into 5, 5 into 5, 5 into 7. And if I take out 5 as outside, it will be like HCF of 3 comma 5 comma 7. So the HCF of three odd numbers, three natural odd numbers will always be equals to 1 only. So 5 into 1, that will be equals to 5. So the highest common factor of 15 comma 25 comma 35 will be equals to 5 here. I hope you are clear with this point here. So what you need to do is, in order to find the LCM or HCF, suppose if common factor is present in both the numbers or the given numbers, you need to take the common factor outside. In the case of LCM concept, if co-prime numbers are present, we need to take the product of those co-prime numbers. In the case of HCF concept, in the case of HCF concept, after taking out the common factor outside, and we are left with the co-prime numbers, the HCF of co-prime numbers will always be equals to 1, that we discussed in the model 4 or method 3 just in the previous slide only. So this is about method 4 here. And let us discuss about the last one, method 5. So this is also I am comparing this one with the LCM concept here is LCM and HCF. Why I am comparing this one with LCM and HCF is, so it will give a clear clarity in which method how we are approaching each question here. Suppose I has to find the LCM of 6 comma 9. So here, so if given number, numbers are in if given numbers are in prime basis, how to get the LCM or how to get the HCF? Suppose here both are of, suppose LCM of even numbers will always be equals to even only. LCM of odd numbers will always be equals to some odd number only. So remember this point. LCM of even numbers will always be equals to even only. LCM of odd numbers will always be equals to odd numbers only. Suppose if this can be written as what? LCM of 2 into 3 and 3 into 3. And if I take out 3 as comma outside, LCM of 2 comma 3. So LCM of 2 comma 3 will be equals to what? Simply the product. Why? Because 2 comma 3 are the co-prime numbers. So 2 into 3, that will be equals to what? 9 2 is of 18. So the LCM for 6 comma 9 will be equals to 18. And that we discussed in the previous examples also. A similar case, HCF of 6 comma 9 I need to find here. So for this also we need to take out the common factor outside. It's just very similar to the previous method only. So 2 into 3 and 3 into 3. And if I take out 3 outside, HCF of 2 comma 3. So HCF of 2 comma 3 will always be equals to 1. So 3 into 1, that will be equals to 3 here. So for this also HCF of even numbers will always be equals to even number only. HCF of odd numbers will always be equals to odd number only. Suppose let us consider one example here is I need to find the HCF of 210 comma 495 comma 980. I need to find the HCF of 210 comma 495 comma and 980. So and some options are given for this. So options are 10 comma 15 comma 5 comma and 20. Need to find the HCF of 210 comma 495 comma 980, and the given options are like 10 comma 15 comma 5 comma 20. So whenever this kind of approaches will present, so what you need to think is there any divisibility rules will apply? So divisibility of 3 or 9 will present in the given numbers or not. So if you observe here, this 210 can be written as 3 into 2 into 7 into 5. So 3 into 2 into 7 into 5. Suppose 2 5 is of 10, 7 3 is of 21, 21 into 10, that will be equals to 210. So here I am finding 3 multiple here. So in the given options also, highest common factor also 3 has to be present. So here this 15 can be written as 3 into 5. So directly my highest common factor will be this 15 only. This highest common factor will be 15 only, irrespective of the other numbers here. I hope you are clear with these problems. And let us continue with some problems based on this highest common factor or HCF concept for better understanding of the concept here. Let's move to, or let us start some. Okay, let us also consider some points here. Suppose in up to now we discussed how to approach or how to solve the questions based on HCF concept. Here I am discussing one more similar or easy concept here. So I need to find the HCF of 12 comma 18. So what I discussed in the methods here is so what you take, so HCF of, so this can be written as 16 to 2 and this can be written as 16 to 3. So take 6 as outside. So HCF of 2 comma 3. So the highest common factor will be 6 here. So this is when if I go with after getting 3 steps here, I am getting the answer as 6 here. So forget about that concept here. Now we are discussing one of the easiest method to find the HCF of the given numbers here. What you need to do is, but you need to take the difference between, the numbers. So what is the difference between 12 and 18? So the difference between 12 and 18 will be 6. So this will be the highest common factor. Suppose if in the given option 6 is not present here. Suppose what are the factors of 6 here? So the factors of 6 are 2 comma 3. So the factors of 2 comma 3. So whatever may be, what will be the highest among these? So 3 will be the highest common factor. So 3 will be around. Suppose if 3 is not present in the given option, our next choice will be equals to 2 here. So likewise, you need to go for the, suppose in the previous also we consider one more example here, LCHCF of 15 comma 25 comma 35. So what I told, take the difference between the two numbers. So what is the difference between 15 and 25? The difference between 15 and 25 is 10, and also the difference between 15, okay, 25 and 35 is also 10 here. Suppose if I consider these two numbers, what is the difference here? So here the difference is again 20 here. The difference is again 20 here. Suppose the highest common factor is that factor has to be present in all the given numbers. So, but 10 is not present in the 15 and 10 is not present in 20. So, I need to go for the next factor, that is 2 into 5. So, if you observe here, 5 is present in all the given numbers. So, highest common factor will be 5 here. Likewise, you need to go with this method. Suppose if you are not familiar with this method, you can approach with any of the 5 methods that we discussed in the previous slides. I hope you are clear with this IHCF concept.